you can back up Unix, Linux, and Windows operating system binaries and instantaneously recover those in the event that one of those gets corrupted. Much, much faster and more efficient than doing a bare metal restore or recovery from tape. There are off-the-shelf products that allow me to utilize the power of snapshots to rapidly recover all of my critical databases: Oracle, SAP, SQL, Exchange, SharePoint, etc. And as an example, if I have a 300 gigabyte Oracle database and I've backed it up to tape and I need to recover that entire database, the time to recover that will probably run about 4 hours. And that assumes everything goes right and I can actually read my tapes, etc. Using off-the-shelf products that leverage the capabilities of snapshots, I can actually do that recovery in about 5 minutes. So very, very efficient and very, very safe and effective recovery of critical databases. There are also products available on the market that leverage snapshots for recovering my virtual machines, whether those are the virtual machines running student desktops or back-end processes. Some of the neatest technology associated with virtualization and rolling out courseware in classroom environments is cloning. I can use cloning to very efficiently create new courses. What cloning does is it takes an underlying set of data or blocks of data and allows a number of users or developers to use that same core set of blocks of data. So rather than have to take my courseware and replicate the code over and over and over for everybody on my development team, I can have them all point to that one central core set of data. It saves a tremendous amount of space. But the really compelling thing about cloning is in the way it allows me to roll out new courses. Once I have built a golden image of a desktop environment for a biology class, for example, all I have to do is clone that out to the number of students that I want to have that, and it will instantaneously create the virtual machines to run that biology courseware for all of my students. So it's a very, very cost-effective and efficient way to do this out, to roll these classes out, and also it saves a tremendous amount of space because, like in my development example, all the students initially are using a common set of information, and it's only as they create new content that they will actually consume additional space on disk. Finally, with the correct grouping or selection of client and network and back-end security products, I can provide secure remote access to my students to their desktops, to their virtual desktops running in the data center. Furthermore, using a product set called Virtual Application Suite, I can limit what my students can see. In other words, when they sign on, when they authenticate to the system, they don't see the operating system or anything else. They sign immediately onto the courseware that they should be using, and they don't have the opportunity, whether intentionally or unintentionally, of modifying anything else in the system. So what does it take to create a virtual desktop environment? What are the components I'm going to need? Well, first of all, I need some kind of a device. It can be in a super thin client. It can be a fairly fat thin client, if you will, with basically just the hardware, the hard drive removed. Thin clients come in all kinds of technologies these days, both desktop versions as well as laptop versions. They have Wi-Fi capability. Just about anything you can imagine in a regular PC is now available in a thin client format. I'm going to need licenses for the virtualization layer, whether from VMware or Microsoft or Citrix. I'm going to need to continue to pay Microsoft for their Vista Enterprise licensing and support. I'm going to need sufficient servers on the back end to run these virtual machines for the desktop. And I'm going to need to look closely at the bandwidth I have and the availability I have in my network. And finally, that all-important network storage that I keep bringing up. So let's do a little head-to-head comparison here and think about the benefits of virtualization versus a conventional PC deployment. The first 6 lines here kind of represent the 6 big headaches associated with dealing with PCs. First of all is the security. Anytime I have data that's sitting out at the end of the wire in a classroom or anywhere else, even in the administrative back office, that data is vulnerable. The more that I can do to move that data back to a central site where it can be managed I'm going to enhance the security of my environment. The second one, it has to do with the management aspect. And as I said earlier, the most important and the most expensive component of managing a classroom environment has to do with just the ongoing care and feeding of all those PCs. Having the ability to have my virtual machines running in the data center as opposed to having the physical machines out there on the desktop allows my administrative staff easy administration for things like operating system patches and courseware updates at any time, and they can do it without actually going out physically to the end user device. Finally, I have the ability, as I mentioned earlier, to very rapidly deploy new courseware through cloning technology. So as I mentioned before, one of the problems in some cases with conventional PCs, let's say we've got one in the biology lab, if the courseware and the student's data are actually on that PC, he can't get to it unless he's sitting in front of that PC. For him to have his virtual machine running in the background in the data center means he can basically access that data anywhere he wants and get much better utilization out of that courseware. The expense of thin clients is typically quite a bit less than a conventional PC, but that's not really where the savings comes in. As suggested earlier, that it's really the care and feeding of PCs that are the most expensive component. Just the deployment of thin clients is much quicker than full-blown PCs, and if I have a thin client fail, to be able to replace that only takes me a matter of minutes. Since the student's desktop is running in a virtual machine back in the data center, if I have a thin client fail, the virtual machine doesn't go down. I simply have to unplug the virtual machine, or the thin client I should say, from the desktop, plug in a new one, and the student's back up and running in a matter of 2 or 3 minutes. Thin client technology is inherently a greener solution than traditional PCs because they have fewer moving parts and they typically have less robust processing power. They require less power and produce less heat than conventional PCs. One of the most compelling reasons to move to virtualization and to networked storage is the fact that I can be sure that I'm backing up all of my courseware and all of my student data across the entire schoolhouse. This can be very difficult to do when I have a lot of departmental systems and I have data residing out on desktops. When I have everything centralized, I can automate the backup and recovery of all this data, and I can ensure it gets done. Now, when it comes to the capital outlay, there will be expenses associated with either one of these solutions. You'll have to either refresh your conventional PCs from time to time, or you'll have to buy thin client technology. If you already have, for example, a pretty robust network, you may not have to do anything when you move to thin client technology. If it's not robust, you may have to spend more money there. There will be software licenses required in both environments. For example, Microsoft charges the same amount whether it's running on their products are running on a virtual machine or a physical machine. And furthermore, when you move to a virtualized space, you will have to buy licenses for VMware or Hyper-V, whatever your choice of virtualization technology. The network storage that I talked about is a requirement. If you're already there, then it won't cost you anything more in a virtualized environment. If you still rely on direct attached storage, then it will be an additional expense to move from direct attached storage to a network storage environment. Probably the one area that is more in favor, if you will, of the traditional PC approach versus the thin client approach is the complexity of the solution. I mean, you know how to do PCs. You know how to roll those out. You know the capabilities of your infrastructure and your network, etc. And you have people that understand how to fix PCs. Moving to a virtualization technology will require some education and very possibly some professional services to initially get going. So what we want to look at now is some of the financial implications of moving to a virtualized environment. I don't put this up here as an eye chart. The reason I put this up here is that there's actually a fairly complete return on investment and total cost of ownership calculator that has about 200 different variables, most of which can be modified. And just want to make the point that the information that I'm going to be conveying relative to TCO and ROI information is not arbitrary, but it's based on a pretty granular analysis of the cost of ownership. So this company called Alinea was commissioned by VMware to write a calculator specific to the virtualization environment. The guys at Alinea, actually, most of them came over from Gartner. They were kind of the TCO experts there, and they formed their own company. At any rate, the model takes into account the unique requirements around a number of different industries, everything from banking to oil and gas exploration to education. And what I picked for this analysis is the primary and secondary education market. I left most of their assumptions alone. One of them I did change was the current cost of a new PC. Their assumption was $1,000. I decided to make that more conservative and make it $700 per PC. We're looking at 500 desktops, and that can be a combination of either administrative desktops or classroom desktops. And some of the other key assumptions that we made was that we're only modeling the benefits of desktop virtualization. We didn't include any potential benefits from data center server virtualization. We also assumed that we would not re-provision any existing servers or desktops. In other words, we're going to go out and buy new servers for the back end, and we're going to buy new thin clients, including mice, monitors, and keyboards for those new thin clients. And finally, when you look towards the bottom of this slide, you see a $17,000 figure for professional services. That's the effort that would be for just the VMware deployment. That does not include, for example, if you needed help deploying network storage. So with a lot of these things, your mileage may vary, but we think it's a relatively conservative approach and something that's fairly representative. So the outcome of our model shows this. As I suggested at the very beginning of the program, the biggest cost associated with conventional PCs, as represented on the left-hand side of the screen, is desktop management and support. The 5-year cost of that effort is about $918,000. Compared to my virtualized environment on the right, that goes down to about $355,000. Interestingly enough, this information is consistent with a recent study I read, totally unassociated with these guys, that basically demonstrated the same findings. In other words, a given administrator can effectively manage about 3 times as many virtual machines as he can physical machines. So the 3-to-1 reduction in terms of desktop management seems to be consistent in a number of studies. The cost of the new PCs over 5 years at $700 a piece is $350,000. So even if I replace all those with new thin clients, new monitors, mice, and keyboards, the cost of the virtualized infrastructure is less expensive. I'm also going to save quite a bit in terms of power and cooling, over half. Now there on the right-hand side, some additional costs that are associated with the thin client virtualized environment. If you look at the dark pink and the blue bars, it represents the cost for the VMware virtualization software. And then under that, in the gray bar, that's the infrastructure pieces that I've decided I needed. The servers, the storage, the switch ports, etc. And finally, at the very top is that implementation cost for the professional services for VMware. So the total cost savings, given my 500 PC replacement effort, is about $401,000 over that period. If I look at the ROI analysis then, if I take that $401,000 and I divide that by my actual out-of-pocket expenses for hardware and software and services of $631,000, the ROI I get on this is about 64%, or about a 36-month payback. That also translates into about 2 full-time people. And hopefully people that have previously been running around fixing desktops in the classroom can now have their time and attention spent on things that are more productive for the schoolhouse. We can reduce our annual consumption, our energy consumption, by about 217,000 kilowatt hours. And we can accordingly reduce our annual carbon emissions by about 131 tons. Thank you very much for taking the time to listen to this recording. I hope you have found it useful. If you would like to further explore how the virtual schoolhouse solution from CDS might benefit your school, please give us a call. Thanks again.